the speed of light may have been different 10,000 years ago or 13 million years ago than it is now, and may be different in another 1,000 years or so than it is right now.
Keep watching to learn more.
Book 3 in the New Thinking Aloud dialogue series is UFOs and UAP, Are We Really Alone? Now available on Amazon.
New Thinking Aloud is presented by the California Institute for Human Science, a fully accredited university offering distant learning graduate degrees that focus on mind, body, and spirit. The topics that we cover here. We are particularly excited to announce new degrees emphasizing parapsychology and the paranormal. Visit their website at cihs.edu. You can now download all 8 copies of the New Thinking Aloud magazine for free, or order beautiful printed copies. Go to newthinkingaloud.org.
Thinking Aloud. Conversations on the leading edge of knowledge and discovery with psychologist Jeffrey Mishlove.
Hello and welcome. I'm Jeffrey Mishlove. Today, we'll be exploring the constancy of the speed of light. With me is Dr. Edward Close, a physicist. He is the author of Transcendental Physics. He is also co-author with Dr. Vernon Neppe of Reality Begins with Consciousness. And in addition, he has just recently published in an anthology a large new chapter, and the title of the chapter is The Mathematical Unification of Space-Time, Matter, Energy, and Consciousness. And the anthology is titled, Is Consciousness Primary?, edited by Gary Schwartz and Marjorie Woollacott. Welcome, Ed.
Oh, thank you, Jeff. It's a pleasure to be here. I'm excited about it.
It's a pleasure to be with you as well. You know, when I was a child and first hearing about Einstein's theory of relativity, the sort of standard phrase that was mouthed in those years was, there may be only 12 people in the world who understand the theory of relativity. And, of course, the constancy of the speed of light is crucial to that theory, is it not?
Yes, it is. It's a very central concept in it. And I can remember reading somewhere where somebody even said to Albert Einstein that it was said that only 2 or 3 people in the world understood relativity. Einstein was not an egotistical person at all. He's very humble. But he did say, who's the other one?
Because it goes against all common sense when we talk about speed, like with automobiles. If I'm approaching your car and I'm going 60 miles an hour and you're going 60 miles an hour, the distance between the two cars varies at 120 miles an hour. You add the speed. Yes.
We call that addition of velocity vectors. And everything seems to obey that. The difference, I think, is in that, for one thing, to start with, is that the speed of light is so incredibly large, 186,272 miles per second, that it's almost unfathomable. And there's even some suggestion. Now, you mentioned the constancy of the speed of light. There's some misunderstanding about that, in my opinion, because what is meant by the constancy of the speed of light is a very interesting thing, and that is that it will be the same from a given source regardless of the motion of the observer. Mm-hmm. So you could have a light source, and it can be moving itself too. and you could have, say, two people. You can imagine this best maybe on spaceships or something like that, where they're traveling through space, and there's a two spaceships, and there's a third one that's sending a beam of light. Even though those objects, those spaceships, are all traveling relative to each other at maybe very high velocities, when any one of them measures the speed of light coming from that object, it will always be the same in space. The constancy doesn't relate to the fact that light moves more slowly through a different medium, like water. So we have to say that the speed of light is constant in space. If there was nothing that is hampering its movement.
Yet my understanding is that in water or glass or something, if the speed of light changes, it's because it's bouncing around. It's zigzagging, so to speak.
Well, and it's even separated out like in a prism, different colors, because they have a different wavelength.
Yeah.
Will be slowed down some more than the others, and there'll be so the speed of light being constant. Now there's another point that's worth mentioning, in that it's very possible that this constant speed of light is actually changing over time, in the sense that maybe if it was measured very accurately, say in 1800, it might be slightly different than it is now in 2019. And there's some evidence that it's actually been slowing down over time when they go back and take the data from some of the earliest studies. And if it were just measurement error, you could say, well, our technology's better now. We just define it more exactly now. But if that were the case, then if we plot this data, it would all be a scattergram around the actual value. But that's not what we find. We find that it all is shifted upward in the past.
Yeah.
That's a good indication that it was actually faster. So in the sense of time, of the speed of light and time, it may not be constant over time.
But going back to the original example that I used of two cars coming at each other, each at 60 miles an hour, if I'm riding a beam of light and someone else is riding a beam of light coming toward me, and I try to measure how fast it's coming, it won't measure twice the speed of light just because we're each moving at the speed of light. Am I correct about that?
That's exactly correct. The speed of of light is constant, means that whoever measures it, wherever, will get the same value at that point in time.
So the principle of the addition of velocities does not apply.
It doesn't apply. And that's very against common thought. You think, well, that doesn't. But what Einstein did is that this was pretty well suspected and known before his time. But in fact, some of the equations that he worked out were actually worked out by scientists before him, but he looked a little deeper into the subject than people before him had, and said what's happening here is a shortening of time, a dilation of time, and a shortening of space. So this was the new idea, that to explain why this was the case, it was because space and time, as we measure them, was being affected by our motion relative to each other and the speed of light. Now, we normally don't notice that because most of our velocities are, compared to the speed of light, are minuscule. They're very much, very teeny tiny fraction. But if you get even to a tenth of the speed of light, then it starts to come into play. And if you get up to 8 or 10 or 9 tenths of the speed of light, then the change is very noticeable. And that's the Lorentz contraction equations that are used in the special theory of relativity to show how that actually works.
So the implication being that, let's say I'm riding on a light beam, and I look at my watch, the watch won't move. Time has stopped completely at the speed of light.
Yeah, that's a way of looking at it, that mass goes to infinity and time goes to zero at the speed of light. So from the point of view of a photon, if you think of it that way, there is no such thing as time. It's all happening right now, you could say.
Well, and that's a real puzzler, because let's suppose I'm a theoretical space traveler and I realize that because I have a lot of mass, I probably can't ever travel at the speed of light.
Right.
But I could approach it.
Right.
And it would suggest that I might be able to travel from one end of the known universe to the other. From an observer on Earth, that process could take 13.8 billion years.
Yeah.
But for me, riding on the speed of light, it would, in effect, be instantaneous.
Yeah, that's a way of thinking, and that is kind of mind-boggling because it goes against everything we experience. Mm-hmm. And in describing what we experience with respect to light, it seems to be instantaneous because of the limitations of our physical organs of perception. Mm-hmm. Another I think common misconception about this is that that you hear sometimes among people will say, well, Einstein proved everything's relative. And, of course, Einstein would roll over in his grave because he was basically a determinist. Mm-hmm. He basically believed that if we can ask a question, we can find an answer for it. And certainly not everything is relative. Even the relative view of reality from people traveling at high velocities relative to the speed of light is all, with the equations that he developed, is all very predictable and can be calculated down to a very accurate level of exactly. So in that sense, things aren't relative. It's just that the appearance of things is relative to our mass and our motion.
Mm-hmm. I mean, when we talk about the constancy of the speed of light,
yes,
that's the opposite of relative.
Yes, it is. It is, because then it's an absolute value.
There are a number of constants in physics: the mm-hmm. speed of light, the fine structure constant. We've talked in our conversations about the Cabebo angle. Mm-hmm. There are about, a handful of constants like this, and I hear people question, why are these constants fixed at exactly that level? Why is the speed of light precisely, as you indicated, 186,000, some 277.33 miles per second?
Yeah.
Is there any reason why it should be at that value?
Yes, and the answer to that is in that simple little equation, E equals mc squared. Mm-hmm. That is a wonderful equation because if you think about it, it contains all of the primary variables that describe the physical universe.
This is Einstein's most famous equation, probably the most famous equation in all of physics.
Yes, and I would say, like most things that are as profound as that, it's not entirely understood by anybody yet. And one of the things you can derive from it just by doing mathematical manipulations is to solve it for c, for the speed of light, And you'll notice that when you do that, it's equal to the square root of mass over energy. Well, this means that the speed of light is determined by the ratio of mass to energy. So if we live in a universe where entropy is increasing, which is what physics tells us, then that ratio is actually changing over time, and that's another reason there is a mathematical demonstration of why the speed of light may have been different 10,000 years ago or 13 billion years ago than it is now, and may be different in another 1,000 years or so than it is right now.
In other words, the ratio of mass and energy in the entire universe is what determines the speed of light.
Yes. Now, you have to bring quantum physics into this too, because when you said the entire universe, I have to put a caveat on that and say that we realize now that matter and energy are quantized, and that everything is quantized when you start trying to describe it mathematically, so that things don't increase or decrease infinitesimally. So if we are thinking of moving through the cosmos, through the universe, at great distances, then at some point, now, if you're thinking in terms of infinitesimals, you say, well, the effect is always there, but it just gets so very small that we don't notice it. So let's say we're talking about gravitation. If we get enough far away from the Earth, we have no weight. We still have the same mass, but we have no weight. But actually, if things are quantized, that means that at some point there's only one quantum of effect. And if you go one step farther, one Planck unit maybe, or at least one quantum unit of distance, it's zero. So there's nothing in between. It doesn't go infinitesimally. So there may be parts of the physical universe that are unrelated to us, in the sense that it's beyond reach because of quantification.
Now, matter and energy are convertible into each other, and
Yes.
I imagine, given explosions of stars and collisions of galaxies, the ratio of matter to energy in the universe must always be varying somewhat.
Yes, you would expect that, and if you accept the idea that entropy is always increasing, in other words, disorder. In other words, the universe is now running down. I have several problems with the current ideas that, or at least are out there, about the creation and destruction of the universe. For years, people thought maybe that it expanded to a certain point and then collapsed back in on itself and so forth. Now the evidence seems to be that the expansion is even speeding up. I tend to think that this is something that appears that way because of our limited ability to perceive, and that in fact it's kind of like the concept. I remember Einstein said one time in a discussion with one of his friends that somebody said, well, nothing travels faster than the speed of light. And he said, no, what relativity tells us is nothing can be accelerated past the speed of light. There could be other things traveling superliminal speeds. We just would not be aware of them. They could be in the same space where we are, but we would be totally unaware of them because we're limited to...
Like a parallel universe.
Yeah, it could be like a parallel universe or even an encompassing universe.
Where the speed of light, or let's just say that there are particles and waves, all of which move faster than our known speed of light.
Right. Maybe it's 2 times our speed of light. Maybe there's another universe going on that's 3 times or 4 times. That could be perfectly possible. The problem with those sorts of things, and it hampers theoretical physics, in that you can come up with logical explanations of how things might work like that. But then if you say, but there's no connection, we can never be aware of it, then we can't experience it. Then as far as we're concerned, in our reality, in our universe, it's the same as if it didn't exist at all.
Mm-hmm. Well, there's a lot of speculation in physics, to my knowledge, of things like particles that travel backwards through time. Yeah. I think some physicists have speculated they also move faster than the speed of light.
Yeah, there are theories in order to explain quantum effects, which I like to say that quantum weirdness is not caused by reality. It's caused by the incompleteness or the problems with our theories about
they're reality. Weird because we think they're weird.
We think they're weird.
The universe itself probably is, to the extent that it thinks at all, is probably thinking this is normal.
Yeah, the universe has no problem with it. It all works together. So the paradoxes and the conflicts are in our model, not in. We tend to confuse the map with reality. Mm-hmm. And there are some good things about that, because if you have a good map, then you can make some conclusions about the reality, and you can go there and find that they actually are there. Mm-hmm. Like if you have a map of the state of New Mexico and it says something is at a certain place, you go there and find it. You can actually also find things that aren't on the map. Yeah. So the map and the reality are not the same thing. And we forget that sometimes, especially, I think, as theoretical physicists.
And I suppose culturally speaking, most people are still working with the map that's based on the work of Isaac Newton. We're basically, intuitively, most people are Newtonians.
Yes. Our experience, our limited experience, and I like to think of the senses as reduction valves. Mm-hmm. Our physical anatomy, the brain and the nervous system, are not capable, they're not constructed at this point in time, anyway, to be able to handle all of, we're awash in a sea of energy. We only see a tiny slit of electromagnetic radiation. We only hear a tiny fraction of vibrational sound, and we only feel all of it is very limited, so that it can be brought together in our sensorium, in our internal energy. Eventually, all this has to come to consciousness. If it doesn't come to consciousness somewhere, then it's meaningless data. This is what causes people who divorce science from conscious experience to say the more we know about reality, the more meaningless it becomes. Well, it's meaningless as long as it's only matter, energy, time, and space, because then it's data. Yeah. But data, it only becomes information when consciousness is involved. Mm-hmm. So I think that's an important point to remember, and a way to make the distinction between the map and the reality, and not fall into the trap of thinking the map is reality.
Well, now let's come back to the speed of light again. Mm-hmm. If I'm traveling on a light beam at the speed of light going this way, someone's coming toward me at the speed of light this way, so we're both moving at the speed of light, and yet and I measure the velocity of the person coming towards me, or the shortening of the distance between us. Right. And that distance is only being shortened by the speed of light, not twice the speed of light. How do you explain that?
Yes. That's where, that's why you have to go to a model of dimensionality. Mm-hmm. That's exactly why you get into, like in Dr. Neppe and our model is 9-dimensional. Mm-hmm. And the reason you have to bring in other dimensions And I'm very explicit about what I mean by dimension, and I explain a little bit because that word is used in all kinds of ways. Any variable sometimes can be called a dimension, and it is by even scientists. Mm-hmm. But in a model of reality, if you're trying to model reality, a dimension is only something that can be measured in variables of extent.
Extent in space.
Yes, in space or time.
Mm-hmm. Because
or consciousness.
You could call any variable like color a parameter, or you could call it a dimension.
And has been. Uh-huh. But in speaking about our model, the TDVP model, which we defined in the last time, the triadic dimensional vortical paradigm.
Yes.
In talking about our model, when we say distinction, we don't mean just a variable. We mean something that can be measured in a variable of extent, and that includes time, space, and consciousness.
Mm-hmm. Well, okay. So now how does that help explain the fact that the two light beams coming at each other are not, the distance is not being diminished by twice the speed of light, but only by 1 time the speed of light?
This is where this is another way, as we approached in the last talk about how consciousness might be involved with the manifestation of reality. Mm-hmm. This is another way we can get to that same conclusion, because what's happening is that space and time are measured relative to the individual that is measuring them, and there's no such thing as an absolute space and time. And this is, I don't like using the word counterintuitive, because I have great respect for something called intuition.
But it's a head scratcher.
But yeah, it is, because intuitively, based on our experience through our reduction valve
because there are two different ways of thinking about the word intuition, I think. And one is the habits that we form. Through our experience, we think of that as intuition because we form judgments without even having to think about it.
Right.
But the other way you're using the word intuition is sort of a deep knowledge that comes from a profound source within ourselves, which is, some people describe it as inerrant, that some deep place within us has a grasp of the truth of things.
Yes, I've seen evidence of that, I can say, as a scientist, that intuition, it's like all the words we've been talking about. It's used in many different ways. And when we say it's counterintuitive, we mean that it doesn't seem like what we think it should be.
Yeah.
But the intuition that we're talking about, the deeper intuition, is a form of memory, in my opinion. Now, this may puzzle some people, but let's think of intuition as a memory of the future. If time is something different, and all of this gets to this, all of this business that the consciousness is involved, and that time and space are different as measured by different people, different observers, because of their relative motion and the whole picture. From each one, they're all different. As again, your friend Michael Talbot said, this suggests that time and space are something entirely different than we normally think of them as being. So this is why it's counterintuitive. We think of time and space as a backdrop that just exists and everything happens within it. But in reality, what relativity is telling us is that's not true. The time and space are relative to the observer and to the observer's view of things. And so if time is something different than we experience, something that comes out of the mathematics of TDVP, or the quantum mathematics that I call the calculus of dimensional distinctions, is that time, like space, has to be three-dimensional. And there's some mathematical reasons for concluding that. But what does that mean? When I first said this to somebody, it's, oh, yeah, that's past, present, and future. No, that's not what I mean. Past, present, and future just describes one timeline.
Yeah.
So that's really just one-dimensional time. Mm-hmm. And actually, in our perception, we don't even see the time dimension. We only see a quantum piece of time.
So the idea of three dimensions of time is completely counterintuitive in
yes.
the first sense of the word intuition that we use. Goes against all our habits.
But now, if time is actually, in reality, three-dimensional, and we only do not realize that because of the limitations of our organs of perception, but the reality is out there, then we can actually conceptualize this by thinking about space dimensions and transferring that concept to time. If time is three-dimensional the same way space is, then a timeline, which our TDVP with the calculus of dimensional distinctions tells us that that's created by the action of a conscious individual, that action being the drawing of distinctions, making something distinct from everything else, gives it a reality in our mind, in our consciousness, and as we draw distinctions, and I'm going back to an earlier thing, if consciousness is involved and particles and things like that don't exist until they're observed, mm-hmm. the Copenhagen interpretation and extension of that, then we create a timeline, and we're only aware of one. We like to say one point, but in a quantized universe, it'd be one quantum of time. Yeah. That's all we're aware of at the given instant. There's only now in our experience. Mm-hmm. We project the idea of the future and the past because of what? Memory. Now, let's suppose memory could be expanded, and there are different types of memory, to the point where we become consciousness of, let's say, first two dimensions of time. So now time becomes like a plane, making the analogy with space. And then we could see the timelines of individuals, because if you draw two lines, you can, if those two lines are parallel, let's say, then you can actually define a plane within which those two lines exist.
It's sort of hard to conceive of, like go to 6 o'clock and make a right turn.
Yeah. That's, again, because of our limitations, because time, and there are even hints of that with our own world, in that because the world is a sphere and it's turning and spinning, we have the different time zones, and it's already tomorrow in Romania, you know. And so it's a little confusing, but if we step back and say, let's suppose that we had the capability that our consciousness was expanded to the point where we were aware of this time plane, then we could actually see the future a bit. The memory is, let's call it facts or information that is stored in your consciousness. Then there's a memory of this whole line, and it doesn't make any difference from that point of view, whether it's future or past. It's there. Now, it even gets weirder than that, in a sense, in that we talked about the double-slit delayed choice experiment, in that we found out that we could not even say certain things about the past. And this gets back to our friend John Wheeler again, said the past is not made up of an iron thing that exists. It only exists as what we can remember or say about events in the past. quantum physics has told us that that the particles that we think of as moving, like make up the individual bodies of the observers in the picture that you painted of people traveling toward each other at high rates of speed, that none of these actually exist until they exist in consciousness. And this is a way of explaining the double-slit experiment and the delayed choice experiment, which are also counterintuitive in the sense that we were talking about. So when you see that, oh, there's a bigger reality out there than we're capable of knowing about, then you can start to visualize a two-dimensional space, or even a three-dimensional space, three-dimensional time, because in order to see a plane, you have to be in the third dimension. Mm-hmm. This is what I call an invariant characteristic of dimensionality. You cannot be aware of and I'll bring in a term, domain. Again, in this context, domain means a dimensional region or space. So a portion of a three-dimensional space is a domain. You cannot be aware of a three-dimensional domain unless in some way you're in a fourth-dimensional domain so you can look at it. Mm. So in reality, people say, well, we only experience three dimensions. Not true. We experience 5 dimensions because we can conceive of the 3 dimensions of space. We have a dimension of consciousness. This gets to the idea of consciousness being measurable in the same way that space and time are. We have an awareness of a dimension of consciousness, at least one dimension, because that's our consciousness as an individual. And we have an awareness of one dimension or one quantum of time. So we've got 3 dimensions of space, 1 dimension of time, and 1 dimension of consciousness. Mm. So the average person is actually aware of 5 dimensions if he's a conscious person.
Well, wouldn't it also imply that since you've now described 5 dimensions, that you're actually looking at those 5 from a 6th?
Yes. It implies that they can't exist in a way that you can conceive of or of a way that you can be aware of. That's consciousness. People say, well, that's awareness. No, awareness is what consciousness does. Mm-hmm. And you can be aware of X number of dimensions if your consciousness exists in a way that there is an extra one. This is what I call dimensional extrapolation.
In psychology, we use the term metacognition, which is a way of, sort of seeing whatever you're doing right now from a larger perspective. But I don't think that's normally thought of as a larger perspective, meaning an additional dimension of space.
Right. No, in our model, that is exactly the difference. And that is that these domains exist because as we become more and more aware, we're more aware of a larger domain and a larger number. I would even maintain that it's possible and that there have been and are individuals who are aware of a larger number of dimensions, just the way we're aware of those 5, of 3 and parts of 2 more. They're aware of the whole thing. So in that way, you could explain a person like, a Buddha or someone who can see another person's timeline. Mm-hmm. This could explain an individual, and this thing is, consciousness is such that individuals can develop certain parts of their consciousness more than other parts. So you could have an individual who would seem to be clairvoyant or telepathic or have some sort of psi ability. And I bring this in because this is the beauty of TDVP. It brings these phenomena, which we do experience and which have been verified through experimental evidence by people like Dr. Schwartz and others who are working at, and Dean Radin is a good example, at IONS. These people are showing that, hey, these things are real. Now, they may not be something that all of us have access to, but it's a difference in the level or the amount of expansion of consciousness. So a person expanded consciousness, and I'll bring in the term that I call cosmic consciousness, would be someone who is in alignment and is aware of all the different dimensions and domains that make up reality. This sort of person would be an amazing person to be around, because he would, just by looking at you, he would be aware of your past, your present, and your future.
For convenience, call such a person a clairvoyant.
Yeah.
It may not be the best term, but what you seem to be suggesting is because they have expanded their consciousness to additional dimensions of consciousness, that gives them access perhaps to these invisible dimensions of time and the ability to see things that are inaccessible to other people.
Well, this brings up another concept that's important in my view, and that is the nested, I would call it, quality of dimensionality. If you think about the three dimensions of space, one dimension is a line, the way we think of it. 0 dimensions is a mathematical singularity, in other words, a point. Now, in a quantum world, there's no such thing. It would be a quantum of space, not
very, very tiny, but not 0.
Right. But if you think about it then, a one-dimensional domain, if you like, is a line, and there are an infinite number of zero-dimensional domains in that line. If you expand to the next level, the two-dimensional domain, there are an infinite number of one-dimensional domains in the two-dimensional domain.
In a plane, an infinite number of lines in a plane.
And if you extend to the third dimension, there are an infinite number of planes in a
solid
volumetric. So extending that on, this is dimensional extrapolation into the fourth dimension, which is time. The first dimension of time is the fourth dimension. And that means that when we think in terms of time, it's much more subtle than the dimensions of space. But when we think in terms of time, then we're already encompassing the three dimensions of space. So I would maintain that this invariance continues on, as I say, like dimensional extrapolation, so that it's like the Russian dolls. All of these domains are embedded within each other. And if your consciousness is expanded to the point where you have awareness of 9 dimensions, you also have awareness of all the dimensions that are contained within it. Now, as I've said before, there are individuals who may have expanded some of their ability, and this, let me put the idea of senses, the sense organs and so forth, and psi abilities, like the ability to do remote viewing, let's say, into this context. An individual may develop one of these abilities, that what a fully enlightened being would be one who has all of them and has developed all of them. But that doesn't mean that there couldn't be individuals who might be able to look at you and tell you things about your past that they wouldn't have any way of knowing in the normal sense of the word.
Well, I think it's fair to say we can make a distinction between a fully enlightened being, if such a thing exists, as opposed to a clairvoyant, a talented clairvoyant. They're not identical.
They're not identical. This is one, if you go to the Eastern traditions of Buddhism and Hinduism, you're talking about a Satguru, a guru or a teacher who has reached some level of enlightenment that's far beyond the average person. And I would say that ability is just like intelligence or athletic ability or anything else. At a given point in time, there's a distribution, so that individuals, some will fall at the average or the median, and others will be out on the tails, one or the other. Mm-hmm. And as I guess this is an optimistic view of reality, as this evolves, as this progresses, we learn from our experiences and we grow. And I would maintain that we grow spiritually, and that spiritual evolution is actually the driving force behind physical evolution or any other kind of change.
You seem to be suggesting that these paradoxes relating to the speed of light and other paradoxes in physics are sort of, they function like Zen koans, and they force us in confronting them as scientists and philosophers to actually modify our own consciousness.
Yes, I believe that. And at one of the Toward a Science of Consciousness meetings in Tucson in 1996, I believe, I bumped into a well-known physicist, and I asked him, I said, "Have you started meditating yet?" And he looked at me as if I was from outer space and said, "No, why should I?" Well, my answer, I didn't have a chance to answer at that time, but my answer would be the scientist of the future will not only develop his abilities to understand intellectually, he will develop his abilities to understand beyond that and expand his consciousness. So in order to do that, a scientist should be practicing meditation techniques and things like this which expand the consciousness, because that's the only way he'll escape the box of materialism.
Well, Dr. Edward Close, you've sort of outlined our next topic right there, because I know you are a deep practitioner of meditation and yoga, and I think that will be a perfect topic for our next interview. But for now, I want to thank you so much for your time and your experience and knowledge, and for being here in Albuquerque with me. It's a real pleasure.
Thank you. I'm enjoying it immensely.
And thank you for being with us.
Book 3 in the new Thinking Aloud dialogue series is UFOs and UAP, Are We Really Alone? Now available on Amazon.
New Thinking Aloud is presented by the California Institute for Human Science, a fully accredited university offering distant learning graduate degrees that focus on mind, body, and spirit. The topics that we cover here. We are particularly excited to announce new degrees emphasizing parapsychology and the paranormal. Visit their website at cihs.edu. You can now download all 8 copies of the New Thinking Aloud magazine for free, or order beautiful printed copies. Go to newthinkingaloud.org.